Hi, everyone. Hopefully you can hear me. I am Neil Flippin. My last name is a little silly, but it's kind of cool. To kind of give you a little bit of background about myself, I studied engineering with a concentration in electrical systems and a secondary focus of chemistry. So I studied electrical engineering and a bit of chemistry. I've had some fun opportunities so far in my career. I worked for Boeing. I've worked for a Berkeley lab. I work for solar design companies, designing rooftop solar for houses, but also for, say, city hall buildings and commercial stores like Walmarts and Targets, or even some of the solar roof ports you probably see kind of driving past some of your local, say, supermarkets or this or that. I've also done a lot of kind of things that weren't related to engineering, but it still got me there. I was a barista once at Starbucks. I've worked at a couple county fairs, and more or less, it's not so much the linear path you have to get there. It's mostly just kind of focusing on your end goal and being flexible with what life throws at you. Um, some good skills you need to kind of be successful. Obviously, as you all know, critical thinking, analysis, kind of look at things at the deeper level, more than just what's at the surface level. A lot of patience and a lot of pattern recognition, because as you know, engineering, architecture, it's a lot of information. You have to make sense, and not everything is instant. You have to investigate. You have to verify. You have to make sure what you're working with and what you're going to produce is going to be accurate. But also too, there's a lot of people skills, because as much as you are a problem solver, you're also making that problem for people who don't necessarily understand the higher levels of maths or science or structural supports or this or that. So you're going to learn, however, it's the easy way or the hard way, you're going to learn how to effectively communicate to people who come from a diverse background in yourselves. Um, and what I currently do at the Berkeley Labs is I work for a particle accelerator project to where we're upgrading it. And as my role as an electrical engineer is I'm making sure all the energy infrastructure for the lab, the particle accelerator itself, is kind of being upgraded. So what does that really mean? I have a lot of spreadsheets on Excel. I have a lot of Zoom meetings just like this, kind of talking to different labs, making sure that they have the right number of conductors and electrical equipment. I'm dealing with very high voltage, high current stuff. So very large transformers you see almost at an energy generation station, and I get to work with a lot of great people, a lot of great scientific minds. And even though my role might be supplementary to what they do, as a result, I'm kind of part of the bigger world of super science, because I get to essentially set up the tools that they get to use to make really cool discoveries and more or less groundbreaking stuff. So let's see here. What did I write? Okay, when you were a kid growing up, what did you want to do? So when I was your age, I didn't know what I wanted to do. I think I took one of those, aptitude tests. My top three were oceanographer slash ocean engineer, race car driver, and I think aerospace engineer. So I thought aerospace engineer sounds cool. We got the rockets, they work for cool companies, and we make a good amount of money. And some other things at the time I was interested in was professional wrestler, maybe being a soldier in the army or whatnot, a DJ, one of an artist, and I did like the idea of working with renewables, let alone solar. Like I said before, when it comes to focusing on the destination, not so much the path itself, is so far in this career of mine, besides being a soldier, and a race car driver, probably an oceanographer, I've done almost a little bit of this, whether it's on my free time or as a hobby, or I was lucky enough to have work experience in these fields. And as you get older and as you kind of get ready to into the adult world, just know that, it's okay to get experience. It's okay to take side steps. You just have to keep your end goal as your end destination, and don't worry about a left or a right turn. So what made me want to become an electrical engineer? At the time of me going through colleges, at least for the state of California, there's a lot of issues of people, local people, say from the East Bay or people from Southern California, getting into their local colleges because everything was full and there wasn't enough money. Hopefully that went away. That was almost maybe 15 years ago. But what made me become an electrical engineer was just looking at the numbers and doing my research. It's a versatile field. I can work in aerospace. I can work in renewables or solar. I can work for super science or Department of Energy. I can work for Google, Apple. Electrical engineering is almost more of an umbrella term for the many things you can do. There's software, there's mechanical, there's electrical, not so much architectural or civil engineering. So maybe where do you place a solar panel on a roof and if it's supported properly? But electrical engineering and of course computer science, it's very diverse when it comes to having a good career where you have enough money to support yourself and your family. It's good at doing that. And overall, it's pretty fun, it's pretty fun. So what does my typical day look like? As I kind of mentioned before, I have a lot of Zoom meetings. I do a lot of AutoCAD. That's something I share in common with architecturals and civil engineering. I do a lot of electrical calculations. And in general, I do a lot of verification of information, and I format that information in reports and spreadsheets that I pass along to my colleagues and we agree upon. What type of projects do I do? As I mentioned before, I get to work with a really cool particle accelerator. If you don't know what that is, essentially it's a device to where scientists and engineers get to shoot lasers through a bunch of magnets. And as a result, you take a typical photon or light particle and you speed it up near the speed of light. And then from there, scientists and engineers can do a bunch of experiments to where they can determine if this type of radiation is feasible for this type of application. And those applications range from nuclear energy, protection from harmful radiation, and a bunch of other cool things. And you kind of get into that realm with super science. And there's actually a couple of particle accelerators in the Bay Area itself. I live in the East Bay, so that's the closest one to me. I know Stanford has their linear accelerator, and then there's also the CERN accelerator in France. Your teachers can also probably go to that link after this presentation, but more information. As a cool little video, what we do at the Berkeley lab, and it should give you a lot more information.
Hi, everybody. I'm Mark, and Emily and I work together at a firm called Skidmore, Owings, and Merrill. And Skidmore, Owings, and Merrill are three people that started the firm in 1936. So we've been around for a long time. And we're a design firm. So we provide design services for almost anything, mostly buildings, although we do some bridges. So in our firm, we have 1,200 people. We design architecture, building services, MEP. So Neil's point about electrical engineering, we have electrical engineers that are focused on buildings, but have a similar background as Neil in education. Digital design, graphics, interior design, structural and civil engineering, which I'm going to talk a little bit more about because I'm a structural engineer, sustainable design, and then urban design and planning. And the principles that we think of are at the bottom. So our firm is about creating design excellence. We are a global firm, so we design in all parts of the world. We have multiple disciplines. So all those disciplines above are a collection of people at our firm that work together. We have research within our firm. We're very active in trying to create a more sustainable world through our designs. And Emily is an architect, but she's also a manager, and she's super important to our firm because she's the one on the front line with relationships and bringing work to the studio and so forth. The projects that you see here are our projects. We designed them. So the World Trade Center, the new World Trade Center in New York is our project. The project in the lower left is a residential tower that is at 500 Folsom in the city of San Francisco. It's a brand new building that Emily was involved with, and I was involved with as well. The Cathedral of Christ the Light in Oakland is a project that we designed. The building on the far right you might recognize. It's a building that we designed. It's the tallest building in the world, the Burj Khalifa. And I saw this noted by a few people in the wordplay that was done earlier. So these are the types of buildings that we design. From aviation, airports, we designed the San Francisco International Terminal. So if you go out to SFO and you drive in and go underneath this building, it's the large building that you see. You can't miss it. That's our design. We don't build, but we design it, and then we hand over the drawings to a builder and they build it. So these are some other examples, and it's a wide range of work from museums to academic buildings, many buildings in the city of San Francisco that we've done, the St. Regis Tower, which is a building you might know. It's near SF MoMA. Adaptive reuse, we take buildings and we reconsider them, redesign them. And then we're also involved with special structures at airports and transportation hubs. So it's quite a range of opportunities at our firm. So a little bit about me. I'm a partner in the firm, and in a private firm, a partner is an owner. So I'm one of 20 owners at SOM, and I'm very proud of that. I've worked very hard to do that. I started at the firm in 1985, so I've been there for over 35 years, my entire career at one firm. The drawings that you see are my drawings. I constantly draw by hand, and I create ideas along with our architects. Several of these buildings that you see in the image on the left are built, and those are models of structures of buildings that we've designed. So drawings are super important. And if you're interested in that, you can make those drawings reality through architecture. And architecture means essentially built art. It's the manifestation of an idea that actually gets built that people can see. Now, engineering, the best way for me to describe it is an application of science. So there's a scientific idea and you find a way to apply it. And I noticed that a lot of people don't know what civil engineering is. Actually, it's the most wide-ranging engineering discipline there is. It's the engineering for the people, which means not the military, but everybody else. So bridges and buildings and transportation and geotechnical engineering, the environment, those are all civil engineers that are trained as civil engineers. And then in my case, I went on to get my master's degree, and that's where I focused on structural engineering. Some of my stops along the way, I went to public high schools, both grade school, middle school, high school. I went to the University of Connecticut, a state school where I grew up, and then to Lehigh University, which is in Pennsylvania. I have an honorary doctorate. I didn't earn it the way in a traditional sense. I was gifted it because of the work. And I was recently elected to what's called the National Academy of Engineering. And it's a very high honor for engineers. It's the highest actually that I know of. And so I'm very proud of that. One last piece is my background. And maybe for those of you that are interested in this, this is how the alignment with civil engineering came for me. I was interested in mathematics and science, but really importantly, studio art and architecture. And that's something I carry with me every single day, is the art and architecture, and I draw constantly. And I think that that's for me, a very rich way of practicing. So that's a bit about our firm, SOM, and about me. And Emily will now take over and maybe tell you a little bit more about us.
Thank you, Mark. So I'm Emily Lawson, and I'm an architect, as Mark has mentioned, and thank you for kind of the intro, Mark. Mark, as he described, has been with one firm for his entire career, and I've actually had a very different kind of a career path. And I'm going to be talking about kind of my career path, what architecture, the process of architecture is, and then where I'm at now. So I grew up in South Bend, Indiana. And when I was growing up, I thought maybe I'd like to be an attorney, a doctor, or an architect. And part of why I chose architecture was because I like doing different things all the time. And I wanted to have a career where I could just have a real variety of experiences. And architecture has been that for me. So one of the things that architecture has allowed me to do is live and work in different places. So I got to live in, Indiana, where I grew up. I've lived in Rome, Italy, in Chicago, Illinois, in the mountains of Vail, Colorado. I live in San Francisco now. I've also lived in New York City and in a smaller town in Oregon. I've also gotten to work on projects in those places and around those places, as well as in Africa, the Middle East, Hawaii, Washington State, Wyoming, Utah, and Michigan. So you can see the map on the right kind of shows you where I've gotten to live and work. I also, like Mark, attended public school in my community where I grew up, from grade school through high school. I went on to get my architecture degree at the University of Notre Dame, and while I was there, I got to study in Italy. And I have a variety of hobbies, and this kind of plays into my interest in architecture. I love art. I love drawing, painting, ceramics. I do lots of different kinds of physical activities: tennis, skiing, biking, hiking, things like that. And I also play the flute and some piano. So for this slide, I'm going to talk a little bit about architecture and the process of it and the skill sets that are involved. So what I'm trying to show here, kind of in the top, is that there are different skills that you can work at as an architect. So some people work at a very large scale, doing city planning or master planning or community planning. So like Mark, all of these drawings are mine, many of them from earlier in my career when I was doing more of the drawing and production. But that drawing on the upper right is showing a resort plan. And there's the little green trees you can see, and there's little brown buildings interspersed in the trees, and there's a central kind of a building with a pool and a community clubhouse. So that's at a very large scale. And then you can also, like most people think of, design buildings, which may be houses or big tall buildings like Mark was showing. So that's a scale that we typically think of architects as working at. But you can also work in interiors. And so kind of in the center of the screen there, you can see a little elevation of a bathroom. So you might be elevating what the tile pattern is in a bathroom and picking out fixtures and faucets and things like that. So there's all these different skills, which makes it a very interesting career in my mind. And I've gotten to work at all those different skills. So just to talk a little bit about the process of doing a design project with a client, I'll just focus on the building aspect. So typically, a client comes to us and they have a site that they're either looking to purchase or they've already purchased, and they have an idea of what they want to build on it, and they have what we call a program. So they're thinking, I want a house here, I want a school here. They have these ideas, and it's going to be this big, and they might even have some ideas about what style it is that they want it to be. So we'll look at that with them, and we look at the site, and we'll look at the community, we'll look at the environment. So what we're looking at is this a hot place? Is it a place with a lot of snow? Is it a place that has rules about how tall the building can be, or a style that the building needs to be? And we'll work with them to lay out on the site what that program is that they're looking for. And we'll work with the community also to figure out what would be the right and appropriate solution for both. And once we start laying that out, then we'll start using various tools to try to understand what that building is. So we might build models, we'll do design sketches. These days, you can do more digital animations and things like that, and kind of come to a consensus on what this project is going to be. And once everyone decides about that and agrees to it, with both the client and the community, then you'll move into a phase that we call working drawings. And that's putting together the kind of a detailed roadmap of what the building is going to be and how it will be built by the contractor. So we do floor plans, we'll look at how the walls are constructed, we'll do things like called waterproofing details. We're coordinating with the electrical engineers and the structural engineers and working all together, this big group of people working together to figure out how this is going to be built. And then once that's done, we go to the city or the local jurisdiction and we need to get permissions from them to build this. So we show them what we're going to do and they say, okay, that looks safe, that looks sturdy, that works for our community, and you can go ahead and build it. So then we get to go into the construction phase, which is actually one of my favorite phases. It's a lot of fun. We get to go out, usually weekly, see what's being built. We meet with the contractors, we work with them if there are issues that come up or they have questions, make sure that the building is being built the way that the owner wants and needs it to be, and get to go through that process. So that's super fun. So then circling back a little bit to me and where I'm at now. So as Mark noted, we work together at Skidmore, Owings, and Merrill, and I am a project manager there. So in that role, what I'm doing is actually more coordinating the groups of people that are doing all that work that I was just talking about. So I will meet with the client, find out what it is that they want to build, work with them to figure out how long it's going to take, how much it's going to cost for us to do that, what team needs to be brought on board. So that's our team internally. So what other architects need to be working on it and what types of other disciplines need to work on it. So we'll need structural engineers. We might need an elevator consultant. If there's a swimming pool, we need a swimming pool consultant. So I build up that team and figure out how to make the project happen. And then I work closely with the owner throughout the project to make sure that we are meeting their needs and their goals. So in that role, I'm an architect, and I just wanted to highlight what the technical requirements are to become an architect. So you need to go to a university, to an accredited degree program, and it can be anywhere from 5 years to 7 years of study in total, depending if you want to just do a single undergrad degree, which I did, which is a 5-year degree, or you can do an undergrad and a 4-year degree in something unrelated, and do a 3-year master's in architecture. So it's something you can decide to do later after you do another career first. Once you have your degree, you do an internship program that's about 2 years. That is something that you're doing while you're working at a firm. It's just fulfilling a certain number of hours in different areas. Once you've completed that, you can sit for your exams. And there are currently 7 exams. They change the number periodically, but there's 7 exams. It's about 24 hours of testing altogether. And then once you pass those, you get your license, and then you need to maintain every year, typically for your license, you need to maintain some additional learning credits and paid dues. And so I'm a licensed architect in the state of California. I'm also a member of the National Council of Architectural Registration Boards and the American Institute of Architects.
I guess I'll go first. I guess for me, traditionally, I would be working in almost like a design studio with my colleagues. We would go over CAD files, we'd be printing out large pieces of papers, and we kind of be routing, just like Mark was saying, we kind of be routing the electrical infrastructure for this whole big building project, essentially what we're doing. But with COVID, a lot of us work from home. Some of us do go into a lab to do inspections or to take pictures, but I guess what's nice, at least for us, is just due to nature of what we do, which is a lot of planning and a lot of coordination in the first place. For us, at least, the world of the Zoom meeting isn't too different what we normally do. So I think it affects us in a positive way to where we don't have to commute and we don't have to fight for parking spots. But I think we did pretty okay during COVID, and it kind of helps out a lot of people not having to commute or do all these crazy things just to get to their office to get their work done. So it's a good side effect of COVID, I should say.
I'll take that as an architect. So architecture, and I may be the engineer, but architecture is this amazing education. You learn so many different things. There's history, there's sociology, there's mathematics, physics. It's a really, really fun career path. And at the time I thought, this is a great preparation for anything. But I will say that architecture school is probably notoriously the most time-intensive program you can get into. Because when we work on our projects, we get really, really into them and really passionate about them. And as my father, who is actually a structural engineer, used to say, the problem with architecture is you're never really done. So in architecture school, the kids tend to stay up all night, multiple nights in a row, working. But the cool thing about it is we're having a lot of fun, and we all like bond and get to know each other and learn from each other. So it's actually really fun.
Yeah, just keep your eye on the end game, because it is a challenge. The engineering and architecture fields are huge challenges, but I think that challenge pays off in the end, because if you do like to see things built and realized, I mean, it's an awesome way to work really hard and then sort of enjoy it in your career. So that's what I would say. It is a challenge, no doubt, but it's true for any field that I think you might really want, and it's just worth working hard for it.
That too, and by being exposed to your high level sciences and maths and concepts, you get to peer into the world of academia a little bit too. You get to have your work published in kind of scholarly articles. You get to go to conferences, meet other people who do a lot of crazy math and crazy physics, because that's kind of one of the rewards of working really hard, is you get to see what your career could be, by keep on working hard and keep on staying focused. And everyone you struggle with becomes your best friend, because not only are you a source of knowledge, they're a source of knowledge. And the further you stick with it, the easier it gets. And you just got to stay focused on the end goal.
I'll quickly say, if you want a career where you never feel like you're working, it's one that I have. So imagine that you never feel like you're going to work every day. That's all I'll say.
I think if you enjoy being creative and seeing your work kind of impact the place that you live and people in your community, that architecture is really gratifying in that way.
And I would say too, to add on to that, if you want to do something that you feel good about, you're not selling things, you're generating solutions, you get to help a lot of people, and you get to maybe inspire some people one day. Architecture, structural engineering, any type of engineering or any type of STEAM field, is just a good bet. So you can't go wrong.